It's kind of wild to think about. But what if a massive public health crisis, one affecting millions in South Africa, actually starts with something tiny failing inside our own bodies? I mean, it's at our cells. Today, we're going to connect those dots, from the microscopic all the way to the monumental.
Okay, first things first, let's just look at the hard numbers. This data from the International Diabetes Federation, wow, it paints a really stark picture. Back in 2021, you're looking at over 10% of adults in South Africa with diabetes. And look at the projection for 2030. It's only going up. This isn't a problem that's standing still, it's getting bigger.
And let's just let that 2021 number sink in for a second. 4.2 million. It's so easy for numbers and percentages to just become, well, numbers. But this is the human scale of the problem we're talking about. To put it in perspective, that's more people than the entire population of Cape Town. Every single one of those is a person, a family, a whole life story.
So to really get what's driving this whole crisis, we've got to zoom in, like way in. We're going from this huge national scale all the way down to the tiny microscopic engine that's running inside every single one of our cells.
And here they are, the mitochondria. Yeah, you probably remember this name from biology class, right? The powerhouses of the cell. And that's not just a cute nickname, it's literally what they do. They take the food we eat and convert it into the energy that powers, well, everything, from your brain thinking to your muscles moving. They are absolutely fundamental to our metabolism.
So, here's the billion-dollar question. What happens when these little powerhouses start to fail? Well, that's what scientists call mitochondrial dysfunction. Think of it like a citywide power outage, except it's happening at a cellular level. It throws all of energy production into chaos and, you guessed it, creates this huge cascade of problems.
Okay, so how in the world does this tiny power failure inside a cell blow up into a national epidemic of type 2 diabetes? It seems like a huge leap, right? Well, let's trace that exact path, from the single cell all the way up to the entire system. It all starts with a domino effect. When those mitochondria aren't working right, the body just can't manage its energy balance anymore. And this leads straight to the classic signs of type 2 diabetes. Your cells start ignoring insulin, they can't use glucose for energy properly, and even the pancreas, the very organ that makes insulin, starts to get compromised.
And here's how that chain reaction really plays out. First, those faulty mitochondria start churning out these harmful molecules. That causes a ton of stress, which, surprise, surprise, damages the mitochondria even more. This whole mess creates a serious energy shortage, and that downward spiral is what finally pushes the body's cells to start ignoring insulin signal.
And this cellular crisis, it's not contained. It doesn't just stay in one spot. Nope. It spreads and hits the major organs responsible for our metabolism. And the effect is, well, it's devastating. Let's break down how this damage builds up, organ by organ.
Let's start with the pancreas. In a healthy state, the mitochondria are doing this constant dance. They're merging and splitting to stay super efficient. But with type 2 diabetes, that whole balancing act gets thrown completely out of whack. The mitochondria start to break apart, they become inefficient, and suddenly the pancreas just can't keep up with producing the insulin our body desperately needs.
Okay, next up is the liver. And here it gets caught in a really vicious cycle. See, insulin resistance can cause something called non-alcoholic fatty liver disease, or NAFLD. But then, and this is the crazy part, the NAFLD, which is also driven by these faulty mitochondria, turns around and makes the body's insulin resistance even worse. It's just a destructive feedback loop that feeds on itself.
Now let's talk about skeletal muscle. This is a huge player in controlling our blood sugar. I mean, our muscles soak up over 80% of the glucose from our blood after a meal. So you can imagine when mitochondrial dysfunction leads to insulin resistance here, it is a massive problem. In fact, it's one of the very first, most critical steps on the road to developing full-blown type 2 diabetes.
And what about fat tissue? We used to think it was just storage, kind of passive, but we now know it's a super active organ. And in type 2 diabetes, its mitochondria are in serious distress. They're pumping out more of those harmful molecules, they have fewer of the good guy antioxidant enzymes to protect them, and even their basic genes for making energy get messed up. The result? The fat tissue itself becomes a source of inflammation that impacts the entire body.
So, okay, we've got this devastating breakdown happening at the cellular level, but that brings up a really important question. Why is it hitting South Africa so hard? Because this science, it doesn't happen in a vacuum, right? The country's unique social and economic landscape acts like a giant magnifying glass for this biological problem.
And this quote from the World Bank, it just sets the stage perfectly. It really boils down to this. You simply cannot understand the health crisis in South Africa without first getting a handle on the deep, persistent inequality that shapes pretty much every aspect of life there.
If you want a number to put on that, it's 63. That was South Africa's Gini index in 2021. That's a measure of income inequality. And what does that number mean? It means South Africa is the most unequal country on the entire planet. And that is not just some dry economic statistic, it has profound real-world health consequences.
You can see that inequality reflected so clearly in the healthcare system. You got this well-funded private sector that serves only about 16% of the population. Meanwhile, the vast majority, 84%, have to rely on a public system that is just chronically under-resourced. This huge divide creates massive gaps in who can get care, who gets diagnosed, and who gets treated for chronic diseases like diabetes.
And if that wasn't enough, the healthcare system is stretched to the absolute limit by something they call a quadruple burden of disease. Think about this. They're battling infectious diseases like HIV and TB. They're dealing with high maternal and child mortality and high levels of violence and trauma, all while also trying to manage this huge surge in non-communicable diseases like diabetes. It's a perfect storm. And honestly, the list of challenges just keeps going. You have widespread low physical activity, not enough funding for healthcare, poor facilities, shortages of essential medication. All of these things pile on top of each other, making it incredibly difficult for people to manage a chronic condition that needs constant, dedicated care.
So wow, with a problem this complex, you have to ask, where do we even begin to go from here? Well, the good news is that this deep understanding of what's happening in the cells gives us a new kind of map. It shows us a potential path forward, one that leads from the research lab right into real life.
So where's the science taking us? Well, the big goal is to figure out how to spot who's at risk and spot them early, using simple biomarkers. From there, the idea is to develop personalized treatments. We're talking targeted nutrition plans and specific exercise strategies that go right to the source and directly improve mitochondrial health.
But look, breakthroughs in the lab are not enough, not by a long shot. To actually get these solutions to the people who need them most, that's going to take real systemic change. We're talking about updating healthcare policies, educating the public on why their cellular health is so important, and getting researchers to collaborate and really accelerate progress. Which brings us back to one final, really powerful question. We started this whole journey with a tiny problem inside a cell. We saw how it can scale up into a massive national crisis, one that's amplified by huge social and economic forces. So the question is, can looking inward to the very powerhouse of our biology actually give us the key to help heal an entire nation? It's a challenge that connects science and society in just about the most urgent way imaginable.